Good day. In this module, let us do a quick recap on the length of line segment. You would have done length of line segment in your other mathematics earlier in the previous week. So let's do a quick recap so that we can further apply this formula into the subsequent questions for this chapter. Now, let's turn to page 89 of your notes and look at the box activity 1. Now on the right hand side of the activity box, you will see a line segment AB. Allow me to actually draw a right angle triangle attached to it. So in order to find the length of AB, we can use Pythagoras theorem since there is a right angle triangle there. So if by Pythagoras theorem, we know that AB square in this case is equals to AC square plus BC square. And AC, the length of AC, the AC is a horizontal line. So in order to determine the line of AC, it is as good as taking the x units of C, subtracting the x unit of A, which gives me 7 minus 1. All right, since it's AC square, I'll add a square there. To find, oops, sorry, there's a missing alphabet there. This one should read BC square. BC square. To find BC, the length of BC, BC is a vertical line. So to find the length of BC is as good as taking the y coordinate. I subtract them, and then I'll get the length of BC, and I'm supposed to square it in order to find AB squared. So if I look at this number, this is 6 squared, this is 8 squared. And if now I want to find AB, I actually can square root this side. And since it is a length, I'll take the positive square root. That is square root 100 to give me 10 units. Right? You will notice that the length of line segment formula, therefore, is as good as the length, in this case, AB, is equals to the x1 minus x2, the difference in the x value of the horizontal line, square it, plus the difference in the y value of the vertical line, and I square it. All right, so this is how that formula came about for length. Maybe instead of length, I should be writing, instead of AB, I should be writing the length. All right, you already know this formula quite well, so let's go straight into the numbers. We are asked to determine the distance. So I will take out my formula, 0 minus 3 square plus 3 minus 7 square. This will give me 9 plus 16 to give me square root 25 to give me 5 units for the first line. All right, determining this is set 1, this is set 2. To find the distance then, again, x value difference plus y values difference. And that puts me at 49 plus 25 to give me 74, and that will give me 8.60. Let me check. 8.6023. And this is a distance, so I'm going to round it off to 3 SF, 8.60 units in 3 SF. Given the points direct, I think most of by now we can all solve. What if it is put into a word problem like this one? All right, we are told that the line 7y plus 4x equals to 28 cuts the y-axis at A and the x-axis at B. You are asked to calculate the length of AB. Well, when they tell you that the x-axis has a point A and the x-axis has a point B and the y-axis at a point A, we already have a few conclusions we can draw. When the point A is on the y-axis, when it is on the y-axis, we know that the x-coordinate is 0. And the other one, B, is on the x-axis, meaning the y value, the y coordinate, is actually 0. Let us use the equation to actually check out what exactly is A and B then. Now, with that equation, 7y plus 4x equals to 28, and knowing that x equals to 0, I can calculate 7y plus 4, 0 equals to 28. So I have 7y equals to 28. My y is actually equals to 4. Therefore, I now know that A is 0, 4. When my y is equals to 0 for B, I know that 7 times 0 plus 4x is equals to 28. 4x equals to 28. X will be equals to 7. So now I know B is 7, 0. With the coordinates of AB, I can now formally find length of AB, which is equals to 0 minus 7 square plus 4 minus 0 square, which will then give me square root 65, which will give me 8.06225. This is a length, so I'm going to leave my answer in as 8.06 units for 3SF. Manageable, isn't it?